Hi guys, welcome to channel. Myself Sanket. I am working as a full stack developer for an IT company. I have won even multiple hackathons and I am a top lead coder amongst the world. So even you can connect me on LinkedIn for your doubts and one-to-one conversations. Even you can visit my lead code profile. I will add links in a bio. Topic for video is try data structure. Trie data structure, which is also known as an prefix tree. So we will today understand what is a prefix tree and how to implement an prefix tree from scratch. So let's start. Let's look first what is an prefix tree. So try basically we can call it as an try. So it is used in systems where autocomplete is required. Basically, when an autocomplete functionality is required, a spell checkers means if you want to check a specific spelling is correct or not. Suppose if you are typing in a input box via Google keyword and it suggests us that and word we typed is an incorrect. In that case, the try data structure is used. The dictionary word lookups. It is used for faster lookups in a dictionary and prefix problem matching, basically solving a problem in a DSA interviews where prefix tree is required. So in DSA interviews, they directly ask to implement even a try data structure from a scratch. So let's see how the structure looks like for an try. So example, we have an cat and another word is cab and suppose another word is bat. So how will the try for this will look like? So first, there will be always an root node. So first there will be an always a root node, and next to it we will basically build a try for now. So we will have an cat here, and next to it is a. So a, and now t. So we have added a cat word in our try. Now next for the cab. Now we will not add again C from here. So this is where the prefix tree is what the prefix tree works. Here the cab will begin from we already have a C, A, and next to it we have a T. But now we will add one more node which is sorry it's B. Okay. Now we are having and we have added another word cab also cat. So we will just erase this. Now we will add a bat. Now for a bat, we don't have a bat B here. We are having a C. So here is no space. So temporary we will add here. So we are having a bat and now A. Now we will not consider this A as this is a part of this tree. We will now add A another A next to this B and now T. Now our prefix tree will look like this. So we have optimized even a space as the both of these parts in these both keywords are common. So we have combined them into a single tree structure. And now add one word difference is added at the bottom that are the leaf nodes. So these are the leaf nodes in tree. the nodes which doesn't have a child are known as a leaf nodes, and the nodes which doesn't have any parent node, that is known as a parent node, that is known as a root node here. So there will be an always a root node in a trie. Okay. So now we will understand intuition to build the trie. So now let's take a same example again. This was a rough implementation. Now how will we know that when to stop the traversal? How will we know that the word is not ended at this position or this position, or correct word ended at this is an correct word? We need to track this part also in Tree. So all this part we will see how to implement this try. So basically here in a try we build a prefix parts, like the prefix for this problem was common, word was common, so we added this as an prefix, and the different characters that were differ in both words are added as a child node for this A, and this is how our try currently looks like. Now let's build a try for this, but with an intuition. So what was the words? Cat, cap, and bat. So cat, cap, and bat. So here we need a firstly a root node. So let's understand how we are going to track this. So basically we will so we will build basically a array here. So this array size going to be 26. As we are having a 26 alphabets in our A to Z series, we are considering only small letters here. So it may differ that your problem has both A to Z and capital A to Z. So in that case, it will be 26 plus 26 size. So here we are considering small letters. So here 26 is a max size we need to consider. So for 26, we are suppose this is dot up to 26, 0, 1, and in array it's 25, not 26. So this is of 26 size. Okay. Now we will build. This is our root. Initially we have an empty spaces here. Nothing is assigned. So for now cat. So we will going to need. We are going to need here one more as it's C. So suppose it's two. So now in Java, other programming languages also, if you want an index for an alphabet, so if we do alphabet, oh, sorry, if we do character minus small a, it will give us index, which is the zeroth index in a alphabet. So what does this mean now? So we will see it now practically. So C, here we are having a C character, and if I subtract 0, oh, sorry, if we subtract an A from it, it will give us second index. So this is a position, a zeroth index position for an C in a alphabet series. So it will give us an index. So now we know that C is going to be inserted at this position. So we are going to insert a C at second index. Now for next part, there is a A. For a cat word, we have inserted a C. Now we need to insert for an A. So for A, we will recursively move two downwards for that node's tree. As it is a prefix tree, each node is going to have its own branch. So for here, we are going to create, going to move to its tree. And for this next A, so we are going to insert an A here. So we are going to insert A here as it is a zeroth index. So A minus A, if we do, it will give us 0. So we have inserted a 0 up to Z, that is 25. This is first index. Now next, now we will move to next index. This is also done. Now we need to insert a T. Then for this, from this A, we are going to have another array. We are going to have another array. So suppose it's 0, 1, to T's index. So for T minus A, it is going to be 19. So for 19 index, we are having a T, and for 26, it's empty. 25th, that is Z, it's empty. So we are array here. Now here, what is the catch? Now for this, we will mark the, this is the end of word, that is EOW. So what does this mean? So if you keep traversing till A, then C to A, now A to T, now we will come to know that this is the end of word, and one of the word from the given array, that is a cat, will complete at this position. So we'll get a cat while traversing this one. So here we will mark a T as an end of word. Okay. Now for we will insert a cap. We already having a C. Now we'll travel to A. We are also inserted an A. Now next we will move to B. Now for this B, we don't have any index till now. Value inserted. So we will insert for it. Now for B, B minus A, which will give us 1. So for this one, we will insert a B. Mark this also as end of word. Now while traversing here, we will also know that there is another word which ends at B and which forms a complete word. So this how we will track that a word has been completed or not. Okay. So we'll erase as we need to insert at this side for the bat. Okay. Now for bat, B-A-T. Now for this index, zeroth index. As we don't have B minus A would give us 1. We don't have here anything. So here we will insert a B. Now next we will going to create a node from this as we need to insert a A. So we will insert a array here now. Array, and for this array we will insert at 0th position A, as A will be inserted at 0. So now next we are going to have a T from this array. We are again going to have an next node, and here we will insert at 19 position a T, so on, and mark this as an end of word. So we have successfully inserted the our three words here: cat, cap, and bat. So now we will traverse them. Suppose we need to find whether a bag here exists or not word. So we will find for B. At bit index we has B. Now we will move next A, and here will move to A as well. So here we are also having a in our this node. So yes, it exists. Now next we will move to next G, but here G is empty. So this word doesn't exist and we will return false. Now let's track another word, that is, let's see for a CA word. Okay. Now here we have a C, correct? We will move to next index, one index, and here also we will move to its child. So here A, and we are also having a A, and here this word ends, but this word is not node is not marked as an end of word, means any word doesn't end here. So this word also doesn't exist in our try. So this is where the end of word plays an important role. So now we will check for a valid case, that is a cap. Now for C we will move to A. A also exists. Now we will move to B. B also exists, and even end of word is true, means a cap exists in our try. So we will simply return as true. So this is how the we will build and try. Now let's understand how we will implement our try here. So we will be having a class. Suppose we name this class as an try, and we need a children for this node. So for children, we will similarly create a try array of children, which will be of size, oh, which will be of size 26 of child of try size 26. Now we will having a boolean flag which we will mark as end of w, name as end of w, and initially it will be so false. This is how our try nodes look like. Each node is a single node, and each will have its children's and a flag to track end of word. So let's see how we will going to implement this. So for root, initially we will create a array and mark this node, initialize this node simply try equals to new try, and it will create this, and initially it all values should be null. So null means here empty. As the node comes, suppose there is a word cat, and for cat, if we do c minus a, we get 2. So for 0, 1, 2, for second index, we will simply add one more new try, and it will not remain null, and it will having a child. If it is not null, if there is something, we will consider in this way. So for this, we will having another try, and in that try, we will insert for the A. Here we will having another try like that way. And for 19 position, here the end of word we will mark as true. So if we keep traversing recursively and reach here, that is cat 012 with 0 index, that is the last index of string, and this node, and compare the end of w and return if it's true or false, we will get whether the word exists in our try or not. This way we are going to implement our try data structure. Okay, now we will see how to implement in this using a Java in our Visual Studio code. So now we will implement a try data structure. So here we are having a plain main Java method and class. Now we will implement. Firstly, we will create a node. So we are creating a class try, and inside this we will have an try array which will name as children, and we will keep as an we will not initialize it here. We will having a boolean flag which will be EOW, that is the end of word, and inside a constructor. Oh yes, inside a constructor we will initialize them. So I don't have formatter currently, so that warning was related to that. We'll just ignore it. Now we will having a public class. Right? Here we will also create a public class, and now basically here we will create our method. So we will name this class as an try implementation. So this is a try implementation. So for now, here we will create a simple try root first. So equals to new try. So this will create a root here. Now here we will write a method. Or we will write a method to insert into a try first. So public void insert method should return nothing, and it will have a root node, a string word that it need to insert, and we will track the index of character for the in a string we need to insert. Okay, if now we will here having a base condition when we will return if word length means the word length we are inserting is equal to word the current index equal to this, then we will simply return from here. Okay, so here we will calculate an index for the current character. So word dot, so it is also suggesting me that so it will give the index for the alphabet where I need to insert. Okay, so what was this base condition is if anyone doesn't understand. So when the IDX is equal to length, means there is no character left, we can simply return. We will not mark the word as end of W true there. I will show you where to mark it the end of word as true. So now we will check that current root dot child means that array has for current index whether it is null means whether it is empty. So I need to insert there a new try at that index. Yes, I need to insert the try at that index if current index is equal to word dot length minus 1 means we are at last character of our word. Now here we will need to mark the end of word as a true. Okay, if not, we will simply recursively call insert method for our root.child. Now here we added a root child. Now we will pass this as an root here. Next word, and we will just increment the index. Now this is how our insert method will work. Okay, simple. Correct. Now we will write a search method. How to find that word exists in a try or not. So boolean search method, it will also take a try, a word. It will return a boolean that whether it exists or not on IDX. Okay. Rather than for simplicity creating a root there, we will simply create a try root here only rather than creating it here. As simple as that. So boolean search method now. If we are at end of word and we have not find an end of word as an true, so means word doesn't exist here. So we will return a false because word doesn't exist here. So again we will calculate the index here. Check if it is null. If it is null, then word doesn't for that particular character we doesn't have a character inserted in our try. So we will simply return as false. So for similar condition for last character we will check whether the end of word is true. If it is true, we will return whether the end of word is true. Else we will recursively call next. That is, we will pass a current children as a root to next recursive step word and just increment the index. Simple. So how it's working? We have written a fallback based condition that if the IDX is equal to length means we have extended the number of characters in an input string. Return false as word doesn't exist. Calculated the index. Check whether if children if the current node doesn't have the particular character means the word doesn't exist in our try, we'll simply return a false. Or else if we are at last character we will simply check whether for that current children index is end of word marked as untrue. If it is a marked as untrue means the it's end of word and we have found a word successfully. We will return as the condition. Simple. So this is how insert and search method will work in a try. So do you understand this? So we can have even a delete method also means it will simply mark the nodes as a null and end of word as a false. In if we want to delete a particular word from a try, it will similarly work as an insert only. Just we need to revert the logic. So you can implement it on your own. So basically, do you understand now that how the try will work here? It's a simple implementation for and try. So if you like it, please Um, like the video, and if you have any doubt, please comment. For more problem related to try, you can even solve this on LeetCode or other platform like GFG for practicing such problems. And this is mostly asked in a product-based companies, as it is mostly used for calculating and not calculating, just search optimization purposes. So it's a common question. So prepare well for this. So thank you guys. मिलता है next video में.